We usually think of distraction as a physical act. You are focused on a task, your phone buzzes, and you actively choose to look away. But consider the alternative. Your phone sits on the desk, you feel the urge to check it, but you successfully resist. You keep your eyes locked on your work. Does that mean you maintained your focus? To answer that, we have to look at how the brain distributes its processing power, a mechanism known as attentional allocation. This diagram illustrates the divide between the orientation and the allocation of your attention. Orientation is the spotlight, where you consciously point your focus. Allocation is the reservoir, the finite pool of central executive processing power running in the background to keep you on task. Keeping your eyes on your work only controls the spotlight. Successfully resisting the urge to look at your phone actually drains the reservoir. The neurological act of ignoring the device requires active processing power. Why does the brain treat a dormant piece of glass as a high-priority target that constantly demands our background resources? The answer lies in operant conditioning, specifically a mechanism called intermittent reinforcement. If you want to train an animal, or a human, to compulsively repeat a behavior, you do not reward them every time. You deliver rewards at unpredictable, variable intervals. The brain learns to anticipate a dopamine release precisely because it never knows exactly when it will arrive. App developers map this exact slot machine mechanic directly into user interfaces. Features like pull to refresh and infinite scrolling are engineered to deliver variable social and informational rewards every time you interact with the screen. Through repeated use, the basal ganglia learns this pattern. It permanently flags the smartphone as a high-priority stimulus, a constant potential source of reward, even when the device is locked and completely out of sight. The phone's mere physical presence traps the frontal lobe in a continuous, exhausting state of active inhibition to override our basal conditioning. In 2017, a team of researchers at the University of Texas at Austin set out to empirically measure this invisible cognitive drain. They targeted a specific metric, working memory capacity, or WMC. This represents your brain's domain general ability to hold, process, and manipulate information in real time. Participants were divided into 3 groups. Some left phones on desks, others used a pocket or bag, the rest used another room. Crucially, every single phone in the study was placed strictly on silent. Later, participants reported they consciously thought about their devices almost 0 times during the test. This chart displays working memory results. Participants with phones right in front of them showed severe capacity degradation. Conversely, those leaving phones in another room demonstrated peak performance. The pocket group fell exactly in the middle, proving mere proximity degrades scores. The physical distance to a smartphone directly and predictably dictates a user's maximum available cognitive capacity, regardless of whether they are actively ignoring it. A common counter-argument is that perhaps the subjects were unconsciously waiting for a missed notification, since the devices on the desks were technically still powered on. The researchers tested this with a second experiment. They instructed half of the participants to power their phones completely off. This matrix charts phone location against phone power. The data shows the phone's power state produced a strict null effect. A dead, powered-off phone on a desk drains the exact same working memory capacity as one powered on and silent. The central executive consumes finite resources to inhibit automatic attention toward a conditioned object, creating a cognitive drain that persists even without the possibility of interruption. Working memory wasn't the only metric affected. The researchers also tested a second capability, fluid intelligence. Fluid intelligence is your brain's ability to reason logically, identify patterns, and solve entirely novel problems without relying on acquired knowledge. On the Ravens test for fluid intelligence, the data showed the exact same penalty. The mere presence of the smartphone significantly impaired participants' ability to problem solve. There was one psychological variable that dictated the severity of the strain: individual smartphone dependence. The Ward data shows the more a person relies on their phone in daily life, the more severely its presence degrades their cognitive scores. The participants who self-reported feeling that they needed their devices the most were the exact same individuals mathematically suffering the highest cognitive penalty from having them nearby. Our highest-order problem-solving capabilities are held hostage by the degree of emotional and behavioral relevance we assign to a nearby piece of hardware. If the presence of a phone automatically throttles your intellect, trying to overcome it with sheer willpower is the wrong tool. Clinical psychology offers a framework for this through acceptance and commitment therapy, or ACT. It starts with a concept called creative hopelessness. This diagram illustrates creative hopelessness. Actively fighting an intrusive thought doesn't eliminate it. It grants that thought more power and burns mental energy. This principle treats process addictions like gambling and perfectly maps onto the attempt to ignore a nearby smartphone. Treating a smartphone distraction as a problem of discipline is functionally bankrupt. Active suppression guarantees the depletion of the very mental energy required to do deep work. The clinical alternative to active suppression in ACT is a practice called cognitive diffusion. Diffusion is the process of detaching a highly salient stimulus from its automatic behavioral imperative. It breaks the tension between the trigger and the reaction. Because modern digital interfaces are specifically engineered to exploit operant conditioning, true cognitive diffusion is incredibly difficult while the object remains anywhere in your immediate environment. Returning to the Ward et al. Data, the only immediate, empirically validated solution to this continuous drain is physical, geographic separation. The modern societal norm of constant digital proximity is effectively a chronic, self-inflicted cognitive handicap. Accessing our full intellectual capacity requires geographic separation from our devices until we successfully decouple our underlying behavioral conditioning.